Hello, today we are going to talk about superposition theory and how it is applied to electronic circuits. I am Fatima from the EC department of the University of Utah. So for starting superposition theory, let's show this theory with an example in nature. If you look at this picture, the water under the boat is equal to water coming out of waterfall 1 plus water coming out of waterfall 2. So it means that these waterfalls acting like independent sources and their total response under this boat is equal to the summation of their responses when they are acting individually. The same principles are applied in a linear electronic circuit. For finding the total response at any point in a linear circuit, you can turn on independent sources individually, measure their responses separately, and then add the individual source's response to get the total response. In other words, in a linear circuit, the total response at any spot, for example, voltage across a resistor in this picture, is equal to the summation of the responses created by each independent source separately. In order to turn on one independent source at a time, of course, you need to turn off others, which means for a voltage source, you are going to replace it with a wire, and for a current source, you are going to just replace it with an open circuit. So now let's show superposition with a practical example in a circuit. This is a schematic of a board we made ready for you, and this is the actual board we built for you. So let's do the measurement and see if the theory really matches with the measurements that we get in this board. All right, so this is the board for superposition, and we are going to measure the voltage across this 2 kilo ohm resistor over here. For the start, let's turn on all the power supplies and see what is the total response on that resistor all together. So let's turn on 6 volts, 9 volts, 3 volts, and we get 1.4 volts across the 2 kilo ohm resistor. Actually, 1.4 is pretty close to what we calculated. The reason that we are not getting precisely 1.4 in here is because there are some internal resistances inside these batteries. Also, these batteries are not made precisely to give us the voltage that we want them to give us. But I'd say 1.4 is pretty close. So now let's turn off all these power supplies. And when I say turn them off, basically we are replacing them with a wire in this circuit. And then let's turn on one at a time, measure the response at the 2 kilo ohm resistor, and see if the summation is going to be the same as 1.4 or not. Let's just start with these 3 volts over here. Turn on 3 volts. We get almost 0.2. Good, it's close to what we calculated. Now let's turn this off. So now let's move on to 6 volt battery and turn the power supply on. We get 0.6 volts, which is pretty close to what we calculated. Sounds great. Let's turn it off and go to the very last one, the 9 volt battery. Turn it on. We get again close to 0.6 volts, and we sum them up, 0.2 plus 0.6 plus 0.6, which is equal to 1.4. That's great. So it seems that superposition works here, and the total response of all the independent sources when they are acting together is the same as the summation of each individual source when acting alone. Thank you.